Okay, today we are going to start building the foundation for evaluating limits without using a table or a graph. So by the end of this note packet, you'll be able to determine limits just by looking at an equation. So we've practiced a lot with graphs, and so now we're going to practice a little bit more with tables just to make sure we have those down pat, and then we will move on and be able to calculate limits, like I said, without or with only the equation in front of you, which is probably the coolest part about limits. So let's go ahead and practice tables a little bit more first though. So go ahead and with your graphing calculator, we're gonna estimate the following limits, and then I'm going to actually show you on your Delta Math assignment just a few examples of the problems you'll have to do. So let's go ahead and first we're gonna change our calculator. We know that in order to plug these equations, or to find the limits of these equations as we approach certain numbers, we have to plug these into our y equals screens, and then we also have to be able to ask our table things. So after we enter the function in, or actually let's do it now, go ahead and go to your table set mode, and we want to change our independent variable to ask. So we want to be able to ask it very particular values of x. Okay, so then we'll go ahead and we'll start with this first one. So in the first table, I've filled out for you what some numbers that are very, very close to what your x is approaching. And so 1.9, 1.99, 1.999. I'm picking numbers that are very close to 2, but slightly less than 2 and slightly greater than 2. And so we should be getting a pretty awesome estimate about what the actual limits are based off of what my y values seem to approach. When filling out a table, and basically always in calculus, you have to use 3 decimal places if you're using decimals. So obviously if the answer is 4, you can just write 4. But if the answer is 4.3625, whatever, make sure you're filling it out to 3 decimal places, okay? So let's go ahead and do this first one. So I already changed my table setting, and now I'm going to go and plug in 3x plus 5 in my y equals screen. Voila. And now I'm going to go to my table. And again, I picked those numbers that are very close to 2, so I can go ahead and plug those in. So 1.9, 1.99. And in the next tables, you'll notice that you're going to have to fill out the x values on your own. And that's because it's to help you guys get a really good idea of what being very close to a number is. And so if you develop that pattern really well, it'll help you both on the Delta Math assignment, but also in the rest of calculus. So it looks like we have here, we got 10.7, 10.97, 10.997, 11.003, 11.03, and 11.3. So what would we say that our y value is approaching as x value approaches 2? Well, I'd probably say the limit of this function is 11. Lovely. And so we can go ahead and we can do those for the rest of these, but we have to now pick our own x values that we're going to plug in. So I'll use a different color for that. We'll fill it in like it's part of the worksheet. So if I'm picking x values that are very close to -5, but not actually -5, I'm going to pick numbers that are slightly less than or more negative than -5. So like -5.1, -5.01, -5.001, and then I can also pick numbers on the other side of -5, so -4.999, -4.9, -99, and then -4.9. And so then we can go ahead and let's do that for the rest of these first, and then we'll just start plugging and chugging in our calculator. So the limit as x approaches 0, so getting very close to 0 but slightly less than 0 would be -0.1, -0.01, -0.001, and then slightly greater than 0 on the other side would be 0.001, 0.01, and 0.1. Last but not least, we have to approach 8. So 8 might be the easiest one to do because you can pick 7.9. I'm not going to cross my 7s. It's just going to take up time. 7.99, 7.999, and then a little bit bigger than 8. And this just helps you be able to see the pattern really well. So I really like being able to pick numbers that follow the same pattern. All right, so let's go ahead and we'll practice on our calculator one more time. If you go up to the top and you can kind of, oops, you can delete these. There we go. So that we don't get in your way. And then in my y equals screen, I can plug in this new equation right here. So we have x squared minus 3/5 x plus 9. So let's go ahead and we'll ask our table for those as well. And I'm not going to go ahead and fill them out in here because that just takes up that extra time. But you guys definitely do because you're not going to have a calculator that remembers it for you. So, or for 3 months from now when you need to go back and study this. So let's go ahead and we plug in negative 5.1, negative 5.01, negative 5.001. Already you should be able to get kind of an inkling of where you think the limit is going to be, but we check from both sides always. All right, so it looks like our limit as x approaches negative 5 of this function seems to be 37, I would say, because if you look right in the middle there, and if you fill them out on your table, it should be right in the middle right here. It looks like that slightly less than 5 is 37.011, slightly greater than 5 is 36.989, so I'd say my final answer is 37 here. All right, let's go ahead and we can try the next section. All those out. Go to my y equals screen. Luckily, this equation is a lot easier. So we have e, and you can use this e or this one over here, e to the x. And we'll go back to my table. We'll try those new values. Negative 0.1, negative 0.01, negative 0.001, and then again a little bit bigger. All right, so looking at our table that we have up here, or the ones that you have written down here now, in the middle section, what does it look like our y value is that is achieved as our x value approaches 0? Well, it looks like we approach 1, so that would be your answer that goes right here. All right, and then last but not least, we have a log, and mostly it's going to be really helpful to just see here how to put a log into your calculator because it might have been a while for you guys. So go to your y equals screen, clear that out, and then if you go to math and you go, I press the up button, or you can scroll all the way down if you would like, but if you go here as log base and then you plug that in, and now I can change my little base that I have going on there, because normally the common base of a logarithm is 10, but in this case we want it to be 2. So I put a 2 in there, and then I go over and stick in that variable x. All right, last one. I'm going to go ahead and try these numbers in my table. So I'm going to start off with 7.9. 7.99. And then numbers that are a little bit greater than 8. Wonderful. So it looks like as I approach 8 from the left-hand side and the right-hand side, and left-hand side and right-hand side on your table right here, it looks like you're getting a y value out of 3. All right. Real quick, before you move on to the next video, I want you guys to ponder on this question for a minute. So without using the table that we have up here, how else do you guys think that you could have found the above limit? So how could you have looked at just this information and gotten 11? How could you have looked at just this information and gotten negative 5? So keep that in mind. Maybe jot down a note right here.